I'm Professor Seth Frey, and this is our second lesson in Python programming. To review, we've learned that Python is a programming language. We can write code that does things. We're going to be learning it in a notebook environment. Notebook environments are composed of code blocks that we can write and run and move around. You're going to encounter errors, which are common. Errors are a fact of life, and you'll get better at dealing with them. And there is a functionality called kernel restart. And if you feel like you broke something, if you're not sure where you stand, you can always restart. And what that does is it doesn't wipe your memory, it doesn't wipe all your progress of your code, but it does wipe Python's memory of how far down your code it is, of which code it's run. After restarting, you'll have to run the first code block, then the second, you'll start running from the top, and on and on and on down to where you left off. The objectives of this lesson, we're going to learn to put together arithmetic operations like in basic algebra. We're going to run sequences of commands, one over the other, to make a code block that has more than one line at a time. We're going to learn how to create and change variables, and we're going to learn what modules are, a little bit of jargon. Every lesson is going to start with boilerplate code that you don't have to understand, you just run it. So we're going to run it, and it's going to set your environment up so that you can make it through the rest of the notebook. We're going to start off just typing out code, running code and typing it out. I have here 3 plus 5, and if we run it, let's cross our fingers, we got 8. The output here, 8. We should feel good about that. It means we're on solid ground. You should just try typing commands out yourself. I know it sounds elementary, but it gets you in the habit. Now, having written that, I'm going to run. And I get 11, just like I'd expect. We're going to encounter here our first check block, or our first try it block. I wrote these to give you constant feedback as you're learning, so that you know you understand, so that you're following along, so that you're interacting with the notebooks and engaging with them actively. So what I'm asking you to do in this one is, you're starting out with ... and I'm asking you to type out 3 plus 5. You're going to get correct, and that means that everything you wanted to happen, happened. When you did this just now, when you ran try it out, it might be because you haven't run all the code blocks above this block. Specifically, it might be that you didn't run the boilerplate code. So make sure you do that. And then this code should work after you run the boilerplate code. So in Python, you can do simple things. You can represent numbers with decimals, 0.5. There it is, 0.5. You can represent fractions, 2 over 3. You can represent, parenthetical operations, combinations of operations. 4 plus 5 minus 3 times 2. What should that be? Let's see, 6, 9, it should be 3. It should come out to 3. Wonderful. So as we run each of these, we'll get just what we wanted. 2 multiplication signs, that gives you exponentiation. So that's 2 to the third, or 2 times 2 times 2, we should get 8. Very nice. In our output right there, just like we expect. And scientific notation, we can also represent incredibly large or very small numbers with the E notation that you might have learned. We're not going to use a lot of that, but it's there. One difference from a calculator is that you can add spaces. So these two lines, actually these 3 lines, 1, 2, and 3, they should all give the same answer, even though they use spaces differently. This one uses no spaces. This one uses lots of spaces. But this one uses spaces in a way that kind of makes sense, in a way that makes it easier to read all this code. What should you do? You should do what makes sense. Don't use commas. So if I was to add commas to 1,000,000 here, my code would break. I would get an error. Oh no, even worse, something totally random will happen. Don't use commas in your numbers. A million has 6 zeros. Just leave it like that. Having made it this far, I've given you a bunch of examples to make sure you understand these basics, how to represent numbers. And now we're going to learn about modules. This is our next section. So when you open Python up, Python in principle can do all kinds of amazing things. Any programming language can. However, when you start it up, it only has access to a bit of that. But you can bring code in from other places. Bring in official code that's maybe up on a shelf somewhere, or code that some other brilliant person wrote that you want to use. And modules are the way you do that. So we're just going to get the most basic introduction to it, access a little bit of extra functionality that's not there when we start things up, but that is there with just one line of code. And this will be useful as we build our knowledge, because especially in this course, rather than expecting you to really rigorously learn all the code, I want to get you to a point. Lots of courses will teach you code from the bottom up. I want to get you to the point of being able to get something useful out of code. So we're going to do a lot of using other people's code and learning just enough Python to be able to benefit from things other people have done. Build on the shoulders of giants, all that. So one such module is called math, and math contains more of mathematics. The way we bring math into our notebook is we type import math and run it. And that'll give us access to things like pi. Pi is not in what we call base Python. It's in the math module. And we access pi. Pi is just a variable. We access it by typing math, that's the name of the module, dot, and then pi is the thing we want. And if we want to access e, the number e, we can type math.e. Do you have to know this? Do you have to memorize it? No, you can look it up. I'll show you how to look into the documentation to really learn what's in every module. But now you're taking my word for it that things exist and we're running them and using them. We can also access functions through modules. So there's a logarithm function that we access in math. And we're going to take the logarithm, in this case the natural logarithm, of e. So we should get something predictable. We should get 1. Do you have to remember that or know that? Do you have to remember all this algebra? No, I'm just giving you sort of my overview. But you don't have to have the freshest, perfect knowledge of everything you've ever learned in math class to be able to understand code. I'm erring on the side of flexing my muscles, of showing you what's out there. If you remember what factorial is, it's 5 times 4 times 3 times 2 times 1. It's in there. Pi's in there. Cosine's in there. So the cosine of pi we can calculate with math, minus 1. If you do want to go under the hood and see what's in every module, we can follow the documentation, the rules, the instruction manual for every module. Every module has one, and here, there's all kinds of other things we can do. Factorial, that's one of the ones we ran. What else have we got? Logarithm, we just ran that, and so on. Cosine. Cosine, we just ran that. Fantastic. This does give us a chance to go a little deeper into something we've learned about numbers in Python that we'd have hoped to get something more concise than e to the minus 16 of this giant number. What's e to the minus 16 of this giant number? Well, it's pretty close to 0. And if you check your old algebra book, the sign of pi is 0. So why aren't we getting 0? Why are we getting an incredibly small number that's really, 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 really close to 0? That's because computers in general have trouble dealing with continuous numbers. They kind of like integers, they like ones and zeros, they don't like decimal points so much. So you're going to get this awkwardness every now and then, and you're going to have to remember that any number with 15 zeros in it is a lot closer to actual 0 than any number you're ever going to be working with in your normal life. You're just going to have to remember that 0. Another little FYI, if you get this error, name math is not defined or some module you want to access is not defined, be absolutely sure that you went up here and you ran your import math code, your import whatever module you got the error for. Read your error messages. They'll give you little hints about what to do to fix them. And here we have a bunch more examples to make sure you understand how to import and deal with functionality that's been imported. There's a lot more modules. There's a lot more in Python that you'll be able to play with in the future. I'm giving you a little just sample of what's possible. Just open your mind up about what it even means to pull in code that was written by other people. But one real just simple example, just to give you a second example of what it means to import, we'll import random, and random gives us access to the idea of randomness, which isn't in base Python, but it is in an easy to access module. What we'll do is we'll get a number 0 to 1, and if we keep running it, we'll get different numbers between 0 and 1. I'm running the exact same code, but I'm getting different answers because that's what we would expect a random number generator to do. But that's not normally the case with all the arithmetic we've learned. So you might be wondering, what do we do if I want a number that's random, but that's not between 0 or 1, that's between 0 and 100? Well, you start with this, and then you can, I don't know, multiply by 100. And we get our little glimpse into how we build from the simplest parts to bigger and bigger things until we have code that's doing something useful. Now we can move along to chaining commands and getting output. So we can run more than one command in a code block. This will take a little explaining. So each of those things, 6 plus 3, 10, 11, those are simple on their own. But if I run this code block, I'm not going to get 3 lines of output. I'm just going to get the last thing that happened. I know that's weird, but that's what's going to happen. My only output was 11. Now, is this a property of Python? It's kind of a property of notebooks, of this coding notebook style of cell blocks, that every block only wants to have one output. It's a little technical, but you kind of have to know it. So just file this in things I know, even though I don't really want to know them. If I was to get rid of that last line, then I would have 10. If I was to add something else, if I was to add 5 plus 6 back, I would still get 10. My only output's the very last thing. If I want to sort of see what's going on in my code the entire way down, I should use something called print. Print's a function. I guess it's the first function we're going to learn to use properly. Here we have the same code as above, but using print. And it's going to print out 2 of the commands, but not the other. So I don't see 10 in there. I see the output of the first command, I see the output of the last command. If I want to see the output of all the commands, here it is, print, parentheses, close parentheses. I run it, and I'll get all 3 lines printed. If Python was really trying to not do you any favors, it wouldn't do anything. It wouldn't do anything on this first code block. Because you never told it to print anything. So why would it show you anything? It's sort of being polite that it chooses to show you anything at all, that it chooses to show you the very last line that it ran, the output of the very last line that it ran. So here we are being thankful for little things that we wouldn't even think matter. It's a complex enough idea, or it's sort of enough of a gotcha, that I've given you examples that you can run through and make sure that you understand this really basic concept so that, again, you can continue to build out from there and eventually be able to do fun stuff. Now we learn about variables. Variables are how we sort of build a memory for Python. The same memory that we wipe when we go to kernel and press restart. So maybe you remember X from your algebra days. X doesn't mean anything in Python for starters. If I run this second code block first, I'll get an error because I haven't done anything. X is not defined. X is not defined. We read our error messages and we get little hints about what's going wrong. That's not very profound when we only have literally one letter typed into a code block. But as your code blocks get bigger, as they do more things, it's useful to get little hints from Python, it telling you what it thinks is the matter. We can define x with the equals sign. And now, nothing happened. We didn't get any output because we didn't print anything. We assigned something. We assigned something to x, and it quietly accepted that new value. If we want to see what's in x now we can run the code. This is what I mean when I say Python has a memory. Python knows things. Python now knows that x equals 6. If I was to go to kernel and hit restart and run this code again, x would have been forgotten until I run x equals 6 again, and then I run my code, and then I get what I wanted. We can treat x like any number. Multiply it by 2 is going to give us 12. We can come with other variable names and use them just in the same way we use numbers in increasingly complex expressions. 2 times whatever w is 4, minus 1 times whatever z is 2. What Python's actually doing here is it sees this line and it says, okay, 4 equals w, I get that. I'm going to remember that. Then it gets to the next line. Oh, okay, whenever I see z, I should just think 2. I'm going to remember that. End of line. Now I'm going to go to the next line. It gets to this last line. And it says, okay, there's a lot there. I'm going to take this one thing at a time. What's there that's really not basic? Well, this open parentheses, that's pretty basic. That I get. This 2, yeah, I know what 2 is. I've seen 2 before. Spaces, I'm pretty open about spaces. I can handle spaces. That doesn't mean a lot to me. It's really going like character by character. Asterisk, yeah, that means multiplication. I already know this. Space, W, oh wait, W, huh. That's not basic to me. Let me check my memory. Oh yeah, that's 2. So I'm not going to try to remember everything. I'm just going to, 4. I'm not going to try to remember everything. I'm just going to replace this this W with 4. Now I'm going to keep going. Close parentheses, I know that. All this stuff I know. Da. Oh wait, Z, yeah. No, I don't recognize that off the bat. Let me check my memory. Oh yeah, 2. So I don't have to remember what Z is. I'm just going to replace the Z that's there with 2. Okay, I think I get everything on this line, so I'm just going to run it now. I'm going to do these operations. I'm going to go back to the beginning, actually, because I know that whenever I see parentheses, that's a bunch of stuff I can make smaller. So this 2 times 4, that's the same as 8, so I'm just going to do that. I'm going to proceed along. This 1 times 2, that's just the same as 2. I'm going to do that. And 2 in parentheses, that's the same as 2. And 8 in parentheses, that's the same as 8. Well, now I'm just down 8 minus 2. And that's 6. So 6 ends up being our final output. It took a lot of steps, but they happened really, really, really fast. So we didn't see any of that. We just saw it do this high-level thing, this 2 times W minus 1 times Z. So I've given you very basic variable names, but we can do more complex variable names. All of these in this block are valid variable names. And when I run this code, I can type in any of those things and get the value assigned. You see that in this case, we have magic sub number. I'm going to call the underscore sub. You can see here we have capital letters. That sort of makes things more readable. It doesn't mean anything. They don't have to mean anything at all. These are all very valid, sort of valid ways that you're going to see out in the world of naming a variable, such as my name. You can have my name all lowercase, my name with some caps, with all caps, with underscore, all kinds of things. I'll run this, and my name is Ursula. These were all different from each other. All these different my names were variants. So capital letters signify a different my name than lowercase. Just like peoples whose names are things. What's a person whose name's a thing? Dirk. A dirk is a name, and it's a kind of a weapon. So lowercase d Dirk is a different kind of thing than uppercase D Dirk in English and in Python. There are rules to variable names. You don't really have to memorize these, but run them through. And it'll give you a sense of what's acceptable. I'm going to check in the examples that you've internalized these messages, and that way in the future, if you get some error message, you can make really sure that your variable names are good. No special characters. Kind of in general, your good rule of thumb: keep it to uppercase, letters, lowercase letters, numbers, and underscores. You'll see a lot of underscores, which is why I call it sub. I say it a lot. Another thing to know is you're not allowed, there's sort of special reserved words. They're always going to appear in green in your code. You can't name a variable true or false because true and false are things in Python that already mean something. You can't define a variable called global or a variable called continue or not or in or from. You can't do that. Those words are already taken. You'll sort of, maybe you'll make this mistake every now and then, but it's a pretty rare mistake to make, especially once you learn more of Python, more of what these reserved are and what reserved words are and what they do. By the end of the class, you'll have used plenty of these. What I'm going to recommend is develop some conditions. Decide what kind of person you are. Am I an underscores person or a sentence case type of person or a sentence case except the first letter type of person? A lot of people are that type of person. I'm not going to be consistent in this class because I want to expose you to a variety of things, but you should sort of pick one in your own code just for yourself. What looks the best, what's clearest to you, what speaks to you, and what's not too much typing. This is a great time to talk about good and bad variable names. You can name your variables anything, but you probably shouldn't. Choose from all possible things. I have here code that gives me 1 plus 2. What's 1 plus 2? Variable 1 plus variable 2, what do they equal? You'd hope 3, but if I run this, they equal 2. Of course they equal 2. I was reasonable. I assigned the variable TWO, those letters, I assigned them the value 2, like you'd hope. But this variable ONE, I assigned it the value 0. So 1 gets replaced with 0 when Python checks its memory, and 0 plus 2 is 2. I'm going to go ahead and say that 0, ONE was a bad variable name for the thing I wanted to assign 0 to. I probably should have named it 0. You can confuse yourself and mislead yourself. There's a little bit of an art to picking decent variable names, but at the basic, try not to use X too much. This gives you just no clue at all about what your variable is, and it certainly doesn't help you. Your variable should mean something. X doesn't mean a lot to me. Let's say that 20, I'm doing some calculation to calculate someone's age or birthday, and 20 is their age. I don't want to name that X. I don't want to name it var, short for variable. You'll see plenty of that. I don't want to name it a variable. That doesn't help. It's not abbreviated, but I don't know what a variable is. It's not an age. I don't want it to be number. Like I know 20 is a number, but it's not. That's still not what 20 means. 20 means how old a person is. So here's some good names. Age is a good name for 20. Number of candles on your birthday cake. That could be it. Or candles generally. Those are, decent. They're a little more descriptive. They give me a little bit more to go on. That number 20 could possibly refer to a person's age, to a person and their age, to how old somebody is. We learned a little bit about output, and we saw very briefly when you assign a variable, basically when you use the equal sign, there's no output. That sounds, again, kind of in the weeds, a little nitty-gritty. It's just something you have to file in your I know this even though I don't want to know this kind of category. Things we memorize for memorization's sake. When I run math.e, I'm going to get an output, this output right here. When I assign math.e, I'm not. A variable now exists. It didn't exist before, so something happened, but there was no output because I didn't print anything. And Python didn't want to do me the favor of printing the assignment. If I really badly want to assign a variable and then double check that it means what I think it means, I can do the assignment and then I can put print afterwards. There we are, and it means just what we'd have hoped it means. Okay, persistence across code blocks. What do I mean by that? Well, magic number means something. We've assigned it. But we haven't defined unlucky number anywhere. Okay, so we should get an error when we run this. That's fine. So the important thing to remember is we defined magic number way, way, way up there, and it still runs. And if we type magic number here, so it still works. So these code blocks, they seem separate from each other, but they're all sort of speaking to one memory, that same memory that we wipe when we go to kernel.restart. And when we go to kernel.restart, our notebook will still be there, but all these variable assignments, all that memory of anything that happened when we ran a code block, anything that should be in Python's memory, all these variable names get wiped and we can start from scratch. If you do kernel restart and you want magic number to work, you're going to have to run way up there whatever code block defined magic number. There is one FYI before we move on. That error that we produced, unlucky number, we could of course make it go away by defining unlucky number. We could also make it go away by deleting it. That's fine, whatever you do. Never submit a notebook to me. If you want credit for it, never submit it if there's errors anywhere. Always make sure if I tell you to produce an error, that you undo the code that produces that error one way or another, that you either fix the error or just delete the code. Whatever you have to do, you'll only get partial credit if you submit a notebook with some errors. So reassigning variables. We created something called magic number. And if I type magic number, I'll still get 1500 because we've been using it for a while. It still means what we thought. But just like I can assign a value to a new variable, I can assign a value to an old variable. What's going to happen? What's going to happen is magic number is going to get rewritten with the value 10. And if I run magic number here, this old one, it'll change. It won't be 1500 anymore, it'll be 10. So we can reassign variables, we can overwrite them. And this is useful because you might think of a variable as some meaning you're trying, instead of meaning that you get right away, it might be meaning you're trying to build over time. So you start with blocks and you keep rewriting and changing the variable until it means what you want it to mean. Code is going to be a lot of the process of creating meaning, abstract meaning. Just be careful. A lot of reassignment can start to make you a little dizzy. So what do we have here? Let's go through this code and sort of build an intuition. We're going to run the code in our head before we run it on the screen and make sure that our head agrees with what we see. A lot of your examples are exactly that. I make you run it in your head and learn, because that is you learning to think like Python. When you learn to think like Python, you're able to write Python and read Python and do things and build things. So let's go and simulate. I have this variable called z1 and I'm assigning it the value 4. Then I'm taking the value of this variable z1 and I'm assigning it to z2. Then I'm overwriting z1 with a new value, 9. And so the question is, what should z2 be? I could sort of convince, if I didn't know better, I could sort of convince myself of two stories. One story is, oh, well, z2 is whatever z1 is. So if z1 changed to 9, then z2 should be 9. That's one story. That's the wrong story in this world. In this world, this is the story you should tell yourself. Z1 was 4. Z2 got assigned whatever the value of Z1 was, which is 4. So Z2 is 4 now. Z1 changed its value, but that doesn't change anything for Z2. Z2 is what it got assigned to be. It got assigned to be 4. It's still 4. When I run this code, I get the value 4. Z2 got assigned to 4, and it stayed that way no matter what happened to Z1. Now again, this is abstract, but these are our building blocks, and this is us learning how to think in code. Making ourselves bigger by learning how to think in as many ways as possible. Here's one thing that's great about being able to overwrite a variable, and this illustrates what I mean by building meaning. Let's say we have a counter. Let's say I'm doing something lots of times and I want to keep a track of how many times I've done it. I might create a variable called counter. I'll assign it 0 because whatever I'm trying to do, I haven't done it yet. But then I'm going to print out counter, and so I should get the number 0 as one line of my output of this code block. Now I'm going to redefine counter as equal to itself, whatever that is, plus 1. So let's see, counter equals counter plus 0. That feels a little weird to define something in terms of itself. But on this side of the equal sign, counter got assigned to 1, so we can replace it, it got assigned to 0, so we can replace it with number 0. What's 0 plus 1? That's 1. So counter now in the second overriding equals 1. And so when I print counter a second time, I should get my second line of output should say 1. Okay, great. And if I just repeat this a bunch of times, I'm going to copy, paste, 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 paste. Counter will slowly grow in value. This is handy. This helps us keep track of things. What does this code mean? In this case, what it means is the number of times I've printed. Initially, I'd only printed 0 times. Then I printed once and twice and 3 times and so on until I'd printed 6 times. You can do other things with counters. Maybe you want to count down. You want to start from 3 and go down until you have 0. I'm going to show you a short. This is actually something we do a lot, is building little counters that go up or go down or that hop up at increments greater than 1. So I'm going to give you this shortcut syntax, plus equals. Counter plus equals 1 is identical to counter equals counter plus 1, but it's a lot less typing. So this is precisely the same code you saw above, but it was less typing and it gives us the same answer. That's great. What else can we use counters for? Well, I'm a batter, and you want to keep track of how many strikes I have and how many balls I have. So with each event, you're going to increment your mental counter until I'm either out or I walk. And looks like I struck out. We have one FYI before we move on. Keep track of this. You see this number here? What's that mean? That means that this is the 74th code block I've run. Now this was the one I ran right before, it's 73. If I run this one again, it'll be 75. This one I run again, it'll go up to 76. What this does, it helps us keep track. Sometimes, this is a practice you want to avoid, but sometimes you'll run code at the bottom or in the middle of your notebook before you run the code at the top. As much as possible, write your code so that it works from the top to bottom. You'll really destroy your mind if you write code that works from the middle out or something ridiculous. Still, sometimes as you're developing and writing and building, it might be the case that you run something below ahead of something above, and these numbers are keeping track of that. Honestly, I don't pay too much attention to them. They're there. You should know what they are. Especially the most useful thing about them is if you don't see any number, that's a line of code you haven't run yet, which makes sense for your examples because I'm not doing your examples for you. You get on your examples and make sure you understand reassignment. So we learned how to do arithmetic in Python. It sounds basic, but it's great to learn something new in the context of something you're at least a little already familiar with. So you've learned all these BARTs, but maybe you don't have a good sense of how we can bring them together to do something. So I'm giving you a little bit of something at the end of every lesson to show you what it looks like to do something useful. We remember math. We can do stuff with math. But we don't always know what we did. Okay, I just did something. What do these numbers mean? What does 470 mean? Why did I produce it from 622 divided by 2 divided by 10 divided by 2.54 all squared and then times pi? What does that mean? If I wrote that and it made sense at the time, but then I came back to it 6 months later, what does it mean 6 months later? If I wrote it but you're coming to it and you see it, what does it mean? Help me out. One thing you could do is write a comment. What is this? This is the number of square inches of picture frame in a 700C wheel. But that doesn't help you. What we're going to do is we're going to use variables to stretch that code out, stretch that operation out to make it so that code speaks to you and has meaning and feels informative. So we're going to start off using variables essentially to narrate the story of code. This next block does precisely what the above block did, but with more typing. More typing is bad because it takes more time. More typing is good because it makes everything less compact and more human readable. Less computer readable, like this first block, and more human readable. So what's it mean? Well, our first line here is import math. We've done that before. Our second line here is diameter 700cc equals 622. Well, diameter 700c, that's the name of a variable that we're assigning. We're assigning it the value 622. Why 622? Well, I Googled what's the diameter of a 700 wheel in millimeters. And I got 622, so we're starting there. Okay, great. I'm going to define another variable. I'm going to define a variable cm2in. What does that do? That converts to centimeters from inches. It's just the ratio. It's 1 over 2.54. Maybe you remember this. There's 2.54 centimeters in every inch. I'm going to create now one variable from older variable. I want the radius of a 700C wheel. I'll get it by dividing the diameter in two. Diameter's twice the radius of a circle. But I want to keep building radius out. I want it in centimeters rather than millimeters, so I'll just divide that number by itself by 10. I'll make it equal to itself divided by 10. And then I'm going to multiply it by this conversion ratio. So these three lines, I come in and radius 700C means nothing. I go out and radius 700C is the radius of a 700C wheel in inches. Well, once I have the radius, I remember my calculation for getting the area of a circle from its radius. I take the radius, I square it, I multiply by pi, and I should get the area. I print out the area, and I get what I wanted. So we did it, and you have to choose. Did you want it done with less typing, or did you want it done in a way you understand? In general, I'm going to expect you do it in a way that you understand, that I understand, that you can come back in 6 months later and get it. So in summary, a lot of stuff happened, but we made it through all our objectives. We learned how to use Python as a calculator. We learned how to chain arithmetic operations, like you might have remembered from algebra. We learned how to use modules, how to bring in more functionality beyond the basics. We learned how to do more than one line in a code block, and what output means and looks like, and what rules it follows in code. And we learned how to create and change and work with variables and build something more complicated out of these little bits, how we can use variables to build something out of nothing. In the process, we learned a bunch of functionality, and that's the end of the lesson. So every lesson you reach, I'm going to expect you to have the right answer in place of ... When you run your code, you should get no errors, and if all that works, if you've made it through all the sort of check blocks, all the try it example blocks, then you're good to go. Thanks for making it through this lesson. I'll see more of you.